I'm going to walk you through post-lab number 2, separating the components of Panacetin. The first 3 questions on this post-lab have to do with your data. You're going to begin by reporting the initial mass of Panacetin, the initial mass that you started with. Make sure that you are not reporting the amount that's recommended in the lab book. You're going to report the amount that you actually used, and also make sure you're writing down all of the digits from the balance. You're also going to report the masses of your recovered and dried sucrose, aspirin, and unknown. So this is just reporting data. After that, you're going to calculate your percent recovery. First, you're going to add up the total mass of the recovered sucrose, the recovered aspirin, and the recovered unknown. So this is going to be just simply taking all 3 of these, adding them up. That's going to be this number right here, the total mass of everything that you recovered. And then you're going to calculate the percent recovery. The percent recovery is going to be the total mass that you recovered. That's what you've calculated right here. And again, that's the sum of all 3 of these numbers. And you're going to divide that by the initial mass of the Panacetin, this number up here. Make sure you multiply by 100 in order to turn it into a percent. This is most likely going to be something less than 100. Next, you're going to calculate the composition of all of the different components of Panacetin. So you're going to do the percent sucrose, the percent aspirin, and the percent unknown. For this calculation, you are going to get the mass of the recovered sucrose. That's this number right here. So the amount of sucrose that you recovered, and you'll divide that by the total mass of the stuff that you recovered. This number right here. Trying to use some color coding, and multiply that by 100 again because it's supposed to be a percent. You're going to do the same thing for the aspirin, the recovered aspirin divided by the total mass, and the same thing for the unknown, the recovered mass of unknown divided by the total mass. These numbers here need to add up to 100%. Once you get those calculations done, you're going to move on to a couple of questions from the lab book. Question number 2, exercise number 2 on page 53. This one's actually, it's not hard, it's just it's a pretty intense question. So it's got 4 different parts to it, A, B, C, D. Each of these is describing a different scenario that would be a mistake in the lab. And it's asking you to evaluate the effect of each one of these different mistakes. So for example, Scenario A says, after adding dichloromethane, you didn't stir or shake long enough. So this, I'm just going to kind of abbreviate this, dichloromethane not shaken for long enough. And the question that it's asking us is, how will that affect the results of this experiment? And specifically, it's asking about how will it affect not the percentages. How will it affect the masses of recovered sucrose, aspirin, and unknown? So to answer this question, you're going to want to start by thinking about at what point, so when is the dichloromethane used in the experiment? Look back through the procedure. When is it used? And then also, what is it used for? What is it used for? What is it doing? It is separating something from something. It might be separating 2 things from a mixture. So what you need to do is identify what's actually being affected, what's actually being separated by the dichloromethane. And if you don't shake with the dichloromethane for long enough, that means that you're not allowing enough time for that one component to get separated from the rest. So how is that going to have an effect? What type of effect is that going to have? We want to be answering what's going to be too high, what's going to be too low. So it's going to be not shaking for long enough with the DCM is going to result in too little or too low of whatever is being removed by the dichloromethane, because it's not shaking long enough with the dichloromethane. So that's going to result in too little or too low of a percentage of whatever chemical it is that's being removed by the dichloromethane. And your job is to identify what that substance is. Is it the sucrose? Is it the aspirin? Is it the unknown? Or maybe it's 2 of these 3. And then as a result, if let's just say that it's separating the sucrose, so that would mean too little sucrose is being removed. That would mean our sucrose percentage is too low, and this as a result would cause our mass to be too high of the other substances. Because, let me try to explain this clearly. If we don't shake with dichloromethane long enough, that means we're not going to be removing whatever substance the DCM is trying to remove. As a result, it's going to be left behind with the other stuff. This is going to cause the mass of the other stuff to be falsely high because it's going to be contaminated with that substance, whatever it might be. So like I said, these are pretty intense questions, and you actually have 4 different scenarios. But for each one of them, this is the strategy that you want to take. When is this happening, and what are we doing with this, and what kind of effect is it going to have? Now, question number 5 is easier. Question number 5 is asking you to write 2 equations, 2 balanced equations for the reactions. You have A and B. There's 2 reactions. Now I'm going to give you a big hint. If you look in your lab book on page 51, you're going to see, it looks kind of funky, it's got a figure on this side, in the upper side, that shows these 2 reactions that it's talking about in this problem. So you're going to write both of those reactions out. You're going to have to kind of interpret it from the picture on page 51. I'm not talking about the flow chart thing that it's got on page 51. I'm not talking about that. There's a chemical reaction on that page as well. So look for that. In addition to writing out these equations, you are also going to be going through and labeling the strong base, strong acid, weak base, weak acid, just like you did in your post lab from last week. So, kind of look back at your post lab from last week, remind yourself how you did this assignment. We started by finding the acids and the bases, and then we used REO to identify the strong acid and identify the strong base. And again, you've got two equations for this one, not just one.